How's this? Good? All right. Hey, my name is Tyler Palesano. Today I'm going to be talking about compiler magic. That was the first title, but I changed it. It's really about what does the decompiler do with anonymous types and Lambda expressions. The other day I was reading a book, CLR via C#, and something that stood out was all the work that the compiler does whenever you use an anonymous type or a Lambda expression. I'll quickly go over what those two things are from a programming perspective, and then I'll decompile them, and we'll see all that it does for us. So what is an anonymous type? It is a C# anonymous type feature allows you to automatically declare an immutable tuple type using a very simple and succinct syntax. So the question is, why don't you always use a class, or why don't you always use something more verbose? And the idea is that you can be very terse with anonymous types. So this is the syntax like so. Oh, kind of duplicates. Anyway, what I've done in this one line of code is I've created an entire type. It has two fields. It has an ID field and a name field, and I'm initializing these fields. This is a whole lot more terse and a lot easier to read than seeing an entirely new class and stuff like that. In fact, this doesn't even have a name, which is why it's an anonymous type. Some of the stuff you get for free from anonymous types, and I'll kind of go through this. You can be even more terse. You can just say new open, what's it called, bracket, ID, comma name, and it infers that the first field is called ID and the second field is called name. You get some functionality out of the box, like the equals operator is overloaded, as is the get hash code operator. The order of the properties matter, so if you do ID, then name, it's different than if you do name, then ID. And it has a built-in toString, so that if you're decompiling or if it throws an exception or what have you, you'll have a nice, easy name that you can read. So for anyone who's been programming very long, this probably isn't very interesting. What I think is interesting, though, is all the work that the compiler does for you. Because, surprise, the anonymous type actually has a name. Whenever you compile this, it will create a name that you cannot create yourself. You'll notice there at the top, that's the code that was replaced by the compiler. I then decompiled it with, what's it called? JetBrains decompiler .peek, if y'all are familiar with that. Anyway, it creates a name. You'll notice at the start of the name is open caret, close caret. You cannot start a class name in C# with this value, but the CLR, which is what will run the interpreted language, it is a valid class name. It doesn't care. It's a generic type. It'll have an int and a string, and it passes them in as a constructor parameter. Then you can see at the bottom, what it actually does is, beside your class, it'll create an internal class. It'll be sealed. It'll give it a generated name, and it'll set these fields accordingly, and it'll have getters for those. So these are read-only types. They can only be accessed inside of your class, so you can't do anything else with them. It's a very handy feature to have. So anonymous types are kind of the easier one of the two between anonymous types and Lambda expressions, but I'll quickly go over what does it do for you. What's cool is if you have multiple anonymous types in the same class, if they're exactly the same, it'll only create one version of that class. So as you can see in this example here, right here we have new ID name, and right below it we have new ID name. It's the same order. It's the exact same property names. Only one class was actually generated for this. However, down here, since it's a different order, or if it had different properties, it creates a second class. So it's very sophisticated, reuses code. I've already mentioned some of that. It prevents naming conflicts because we cannot create classes of this name ourselves. I forgot to mention at the top, I put this presentation and a bunch of code out on GitHub. You can pull it down, run it in Visual Studio Code or Visual Studio. You can actually see as a comment all the decompiled code. For anonymous types, I went ahead and took that decompiled code and made a compiler-safe version of it for C# where I've overwritten equals to and get hash code and stuff like that. It's kind of cool to actually see what the decompiler does and how we can do it manually if we needed to. Now let's talk about something a little bit more interesting, Lambda expressions. Lambda expressions make it handy to create actions or functions, funcs, on the fly. Actions and funcs are really just a generic form of delegates, which back in the day, before we had actions and funcs, you would create a delegate for every event, and you would have multiple delegates, and they would all share the same functionality but have different names. The .NET team was like, hey, why don't we just make actions and funcs, have them accept a generic series of parameters and possibly an output, and then we can reduce a bunch of duplicated code. The next logical step is Lambda expressions, which is just syntactic sugar that allows you to write those in line. For example, let's say we did not have a Lambda expression and we wanted to aggregate a few numbers. The original way to do this is you would create a method. You would give that method to your aggregate function and it would call it. Or alternatively, you could have an inline func parameter, which is what I was talking about a second ago. It accepts 2 integers and it returns an integer, and it also calls that add method. Well, this is a whole lot of code. With Lambda expressions, we can get rid of the add method entirely and just do it inline. You see the open parameter left, comma right, close parameter, Lambda notation, which is the equal sign caret, left plus right, there's your aggregator. It's more terse, it's easier to read. It's not great if you have duplicate code, if you need to do this action later. It's not great if you have lots of code, you can do it. But it's all about readability, and it's just syntactic sugar. Okay. So, what was actually generated? The top line there, just that little bit of code, left comma right, turns into all of this down here. It actually also creates an entire class. That class has a field, which has a goofy name, and you'll notice it also starts with an illegal value. We could not type this in ourselves and compile it. It would throw an exception. But the compiler is allowed to do it because it knows the rules of the common language runtime. The first time it calls this action, it'll set it to a static field, and then it'll call it. So this is helpful if it's in a for each loop. It'll basically act as a singleton. So this is just calling the method. Same as before. In a similar in line with the class, you will have this private class. This class, again, uses an illegal name, creates a singleton, like I said, and you'll see way down at the bottom, or actually kind of near the middle, you'll see that it actually created a static field that is a func, int, which is very similar to what I showed you to how we could do it manually. What's interesting about this is that since it is a static field and its lifetime scope is of static, it will live longer than if you were to have done it the first way. It's a very minor distinction, but it is something to keep in mind. Slightly more memory will be used. Make sense? Anyway, near at the bottom, you can see where it actually does the function left plus right. Now, that's neat, but how does it handle scopes? This is the point, when I was reading through the book, this is the point where I actually said, hey, this is interesting and can help me moving forward. If, when you use an action, it creates a class, how is it possible that this code actually works? I defined n equals 42 outside of the scope of this other class, right line n, yet somehow it still produces the correct value. Well,
You don't have to pass as parameters.
huh?
There are lots of things you don't have to pass as parameters. They're already there in the namespace.
True. In this case, it's a completely different scope, though. This n equals 42 is a local variable, and the other class, if there was no compiler time help, would have no knowledge of this. So what it does is it creates a new class, and it initializes a new field that it then sets the variable to whatever you had. In this example was 42. It actually sets that field in that class for you automatically, and then it uses that field from that point forward. So in this example, creates that class, it creates an integer that it called n, which happened to be the same name that I used, and then it'll write that line inside of that method itself, because that was the action that was given to the Lambda expression. So that's cool, but isn't it possible to change the value of n inside of a action, inside of a Lambda expression? Yes, it is. This isn't something you can normally do. if you use like a pure action or something like that. So how does this work? How is it so that n is written as 5 in this example, because we're setting it as an action, instead of 42? There are actually different scopes because this class was created for us automatically, right? The compiler takes care of that for you by, just as before, it'll create a field called n, it'll initialize it for you, then it'll run the action, which in this case sets n to 5, and from that point forward, it doesn't care about your local variable n that you had originally up here at the top here. It instead starts using the field that it created for you from that point forward. So you see at the bottom, it'll have C display class 00.n, which is of a different scope than just n in the local class. That's pretty much it. Lambda expressions are also very sophisticated. It will reuse a bunch of code for you if you have multiple Lambda expressions in the same class. If they can be combined or if they're similar enough, it'll put them in the same generated class for you, which is nice. It handles scoping for you. And that's really all I got. If you want to see my presentation, you can look me up on Twitter, Palesano. I have my presentation on GitHub, which is linked on my Twitter. It's easier to remember. This was created using reveal.js. Does anyone have any questions I can help answer? Fantastic. Are you ready? Oh, I'm sorry. Yes, sir.
You saw my generated test method
Yes.
that uses anonymous types for the parameters set to the various test cases in the working code.
Very cool.
Because they're easy to set up. You don't have to declare very much. Of course, if you have more than one, then they're all be the same. But except for that, they're pretty straightforward until you have a whole bunch of them.
That's right. Yeah, they're incredibly handy whenever used correctly. It's a very good tool to use.
Does Visual Studio 2017 automatically convert anonymous types to name types if you wish?
Yes. So when I compiled this, I used .NET 3.5, .NET 4.6.1, and in fact .NET Core 2.0, which came out very recently, and they all produce the same compiled code. I included the .NET Core in my. I'm sorry. Yes. Oh, I'm sorry.
Will it let you automatically convert an anonymous type declaration into a name type?
Without a
In
tool?
other words, into a method.
Not that I know of.
Okay.
Yeah, I think the scoping of an anonymous type is very limited.
I wasn't able to find a way to do it automatically.
Yeah. No, if you ever want to use an anonymous type outside of a method, change it to a tuple, because that's the preferred way. And now they have value type tuples, which are a lot easier to use anyway. At least that's what the book said. That answers the question was, can you use anonymous types outside of a class, if I may summarize?
Do the anonymous types, are they dynamic? Like, so
No.
if you, okay.
And you meant the actual word dynamic, like
Right.
it can
But
change.
the C# dynamic class, can you pass it out of a class and take it in as a dynamic?
Oh, I see what you're saying. The compiler will prevent you from doing that. I
Okay.
don't know if there's a way to get around that.
Gotcha.
There's not supposed to be, from what I understand. Yeah. Thank you very much.